Hello, uh, this is a course on electrical machines 2. I am just going to briefly outline what will be the course content and how this course will be conducted. Electrical machines 2 will primarily focus on AC electrical rotating machines. Although it is a class on electrical rotating machines, first module I will devote on static transformers. In order to understand how the equivalent circuit of a transformer is developed, because those ideas will be very much useful in understanding the equivalent circuit of other rotating machines such as induction motors. To begin with, a clear understanding of the windings of any rotating machine is essential to comprehend the subject. For example, unless I know how the conductors are placed in a rotating machines, in which fashion, then it will be very difficult to understand what is going on. A fair idea of three-phase windings of a rotating machine will be taken up first. After we do the windings portion, then we will try to tell you that any rotating machines, be it DC, be it three-phase induction motor, be it synchronous motor, there is a common underlying principle, and that common underlying principle is true for all the machines. So, we will discuss about those points. One can always think that the production of torque in any rotating machines will be because of the interactions of two sets of magnets, one produced by the stator windings, another produced by the rotor windings when both of them carry current. Interaction of these two fields will be responsible to create the torque in a machine. The torque which will be produced will be steady in nature, provided certain conditions are fulfilled. So, those things will be highlighted. The next portion of this course will be how to produce a rotating magnetic field using a polyphase winding. Polyphase means we will be concentrating mainly on three phase. So, how a rotating magnetic field can be produced. This concept is essential in understanding the operation of single phase, three phase induction motors as well as three phase synchronous motors. So, whenever we talk about rotating magnetic field, we must be very clear what is the speed of that rotating field, what is the strength of the rotating field, and in which direction it is moving, and who decides the magnitude of that rotating field. The magnitude of a rotating field, whenever you specify, it is also important to specify it with respect to whom. If the windings are stationary, we will see in the course, and it is carrying balanced currents, then a rotating magnetic field will be produced whose speed will be described, can be described with respect to the winding itself, which is stationary, or it could be with respect to any other observer. Anyway, those details will be taken up. Primarily, for any electrical machines, we would like to know how these machines or motors in general can be started, can be braked so that it comes to a stop, or how its speed can be controlled. So, these are the primary three things for any machines, and it is to be various methods to do those things will be taken up. The analysis of these machines will be primarily the steady state analysis, unless at some points of time I will also tell you about the transient behavior of the machines, which are just bare necessity to carry on with the course, but primarily it will be steady state analysis. And whenever we talk about steady state analysis, we must develop some equivalent circuit of the machines, and under various operating conditions, for example, at different loads, how the torque speed characteristics of the machines will change, how its speed can be controlled under different loading conditions, how the ratings of such machines are specified, and so on. Therefore, once the equivalent circuit of a machine is developed, they can be directly applied to analyze the performance of the machines under various conditions. So, the equivalent circuit for 3-phase induction motor and for synchronous motor will be developed, power equations and torque equations will then follow from it. Single phase induction motor is slightly difficult to understand, but if one has gone through a course on 3-phase induction motor, single phase induction motor analysis can be developed, how to do the analysis can be developed from the concept of two revolving or two rotating fields rotating in opposite directions. Therefore, it is expected that single phase induction motor can be analyzed if we have a fair idea of the rotating magnetic fields. For each of the topics, there will be lot of numerical problems I will try to solve in the class, or I shall give you in the form of homework which you have to submit. Therefore, primary objective of the course will be to analyze performance based analysis of various rotating machines, which will be about 3-phase induction motor, about single phase induction motor, and about synchronous motors. Now, it is important to note that any electrical machines can be operated both as a motor or as a generator. Therefore, motoring and generating operations of such machines will also be taken up in due course, and I hope if you undergo this course, you will have a better understanding. So, I wish you all the very best. If you like, you can take the course. Thank you so much.